Here we are, Tuesday, September 3rd, year of our Lord 2019. Because that's what AD means, right? Former fifth graders. AD means Anno Domini, year of our Lord 2019. Well, here we are. I'm saying this for the sake of the video. Welcome to those in cyberspace. We are starting our second week of school. All the things that we needed to do to lay the foundation for a great pre-algebra year were done last week. The students just turned in their homework from last week, numbers 10 through 20, and then a couple other specific problems we had. From lesson 1.2, I asked on Thursday that you would bring graph paper. Who brought it? So hopefully you have graph paper. If you don't, maybe there's someone very kind next to you that when the time comes and you need it, that they will lend you a piece of graph paper. Thanks, Evelyn. I'll come get those. All right, we spent 2 days talking about, spent 2 days talking about order of operations. Hopefully you got that down pat. You'll get plenty more practice as we go through the year because we're going to have lots of problems that have more than one step to do. Yes, Noah? Noah, it's Tuesday, the first week of grade 4, and you forgot your math book. What am I to do? Go, Noah. So we said that since I didn't alert you about the graph paper then, we're actually going back to 1.1. Back to 1.1. It talks about this thing called a bar graph that you learned about long ago. Let's get some basics about graphing first before, again, Mr. Frank is not the type that we're going to sit there and read through the textbook and read through all the examples. They're always going to be there for you, but we'll talk about the things that are in the lesson. So you'll hear it from me. You'll be able to read it in the book. And again, I encourage you, if there's things you still don't get, there are so many places online to be able to go to and say, you know what, maybe if I hear it from this perspective. It's all about you getting it. So don't feel like if you didn't understand the book, or some days you just don't understand me. I'm not going to be like, oh, why are you going to ask someone else for help? You should do whatever you have to do to get it. Yes, Spencer. Oh, my goodness. Is that why you asked a few minutes ago when the bell rang? Why didn't you say it then? Go. All right. A bar graph. Most graphs start with two lines. One is, what do we call the one that goes up and down, Micah? Just give me what's that? No. Well, if you're talking about the map, he's thinking latitude and longitude, but we've got two axes. You remember that word? Okay? One goes side to side, and we call that it would be the x-axis once we get to that, but it's also, what direction does it go if it goes side to side? Think about where the sky meets the land, horizontal, and the other axis is then, if this one's horizontal, we call that one vertical. So someone might, did you ever do that in gym class? See how high you can jump? Test your vertical leap. All right? So graphs have axes, vertical, horizontal. A bar graph, the reason we use a bar graph is because it's meant to compare things. And the example in the book is comparing volcanoes. You can compare lengths of rivers, heights of mountains. So you've got to have a scale. Remember that word? So if you look, just quickly glance at the example in your book on page, one of the problems I have right now is somehow my teacher's edition is missing. So hopefully I can work through that. If you look on your example on page 5, at the top, you'll see an example of a bar graph where they're comparing volcanoes. And along the left side, they have a scale. You see the numbers on the left side. Each increment, each space along your scale should be equal So if you look at their scale, it goes from 0 to, somebody help me out, 30, and all the way up to 180. And they count by 30s. So if you were to do this on your graph paper, if you were to say that every box was a certain amount, every box has to be that same amount. Does that make sense? That only makes sense that your scale should be equally distributed as you go up the steps. So there's every line is 30, all the way up to 180. Now, why did they make their graph all the way to 180 if you look at their information? Well, they don't give us a table for that, but they would have got this information from a table of information, and they would have put it on a graph. Obviously, they went to 180 because their highest volcano is about how high? I'm sorry, we're talking about activity. The most active volcano has had how many eruptions? Active volcanoes in 4 countries. Which one has the most active volcanoes? Which country?
The U.S.
The U.S. About how many active volcanoes has the U.S. experienced?
Like 170.
Okay, does everybody agree? Spencer looks at that bar graph and he says, it looks like about 170. Because between 150 and 180, if you were to go right in the middle, you'd be at 165. And Spencer says, that looks like it's either right in the middle or maybe a little above the middle. Raise your hand if you get that, say amen. Okay, so what's the purpose of a graph? What's the purpose of it?
To help you stay straight and be losing what I was thinking.
To organize information.
To organize information, very good. Information in this case that we're comparing activity in volcanoes, but what's another purpose? To organize it and?
Maybe instead of just like reading a whole lot of information, you can just look at it real fast.
Exactly. Could the person that made the graph have written a couple paragraphs about volcanoes?
Mm-hmm. Yeah.
What would be easier to understand? To read those paragraphs or to just look at that picture? And even though you're in pre-algebra, you're in junior high, you're in middle school, do you think I could probably go get a first grader, bring them up here, and if first grader that's got the ability to read, and just looking at that picture, do you think they'd be able to say which one had the most active volcanoes? Which country? Yes. And that's the purpose of it. A graph makes things easy to see. It puts it as a picture, a visual, so you don't have to sit there and read text. Makes it more interesting. And it does organize your facts, like that one does at the top of page 5. They have some questions about it. If you go down to example, which country has the most historically active volcanoes? We already said the United States. Which country has the most volcanic eruptions in a given year? Can we answer that question? Can that question be answered on that graph?
No.
Why can't you answer it? Because the information isn't there. That's not what this graph was doing. This graph it had a scale up the left side from 0 to 180, and it had labels. So it's a vertical graph, so this would be the scale, and this is where your labels would go. So when you make a graph, you don't just start willy-nilly start drawing things. You have to have a plan. Am I going to make a vertical graph like they did here, or am I going to make a horizontal bar graph? Can you think of a reason why anybody would make a horizontal bar graph? Most bar graphs you see are probably vertical, like the volcano one. Could you come up with an instance where you'd be like, you know what, I think I'm going to make this a horizontal bar graph. I'm actually going to put the scale down here and the labels here, and my bars will be going from left to right. Can you think of a reason? Can you think of things you might be comparing that would lead you to say, I'm going to make a horizontal bar graph? Yeah?
Like measuring or seeing the length of rivers or something.
That's exactly the one I was thinking as one of them. Length of rivers. If I was comparing the Mississippi to the Amazon to the Nile to the Ohio, I'm thinking of a river flowing. I might want to make that bar graph horizontal. Does that make sense? where I would put the number of miles down here as my scale, and I would label them Ohio, Mississippi, Amazon, Nile. Yeah. Everybody got it? So you know what a graph is. All right, go to page, bottom of page 5. Your turn now. How many more historically active volcanoes does Chile have than Mexico? You can interpret that graph by looking at the bars above Chile and Mexico. And the question is, not how many, but how many more historically has Chile had than Mexico? Anybody got an answer? Again, it's going to be an estimate. It says about how many. Somebody be brave. Bottom of page 5, number 1. About how many? Dominic.
75.
Dominic says 75. He sees Mexico's a little more than 30, and Chile is almost 120. Okay, I'll buy it. Anybody have something different? Because it's not going to be exact.
88.
88?
Yeah.
Now you got really exact there. See. Sydney? Okay, Sydney looks at this. She sees it's just above 30. So her estimate is 30, and the other one is just below 120. See what she did? So we're not looking for an exact answer there. So I would buy 90 because she's going by the closest lines that are there. I would also buy 85 if someone said, well, it's a little above 31, a little below 120. Does everybody get it? But the point is, it's easy to just look at it and compare them. That's what a bar graph should be. Which country has the least number of historically active volcanoes? That should be so easy. Elise, look at that graph. Which one has the least active volcanoes? Canada. Beep, turn the page. So a bar graph is meant to compare. Then we've got something that looks like a bar graph. And frankly, you don't use this very often, as you do a bar graph. But it looks like a bar graph, except usually when you make a bar graph, it's very important that you make your bars and you have a space between your bars. So a normal bar graph and if I was a good artist, you would also, not only would your scale be equally distributed, 30, 60, 90, you would have equal amount of space between each bar, right? And if you're nice and artsy, you color them, have a nice color-coded bar graph. But there's space in between the bars. At the top of page 6, you're introduced to, has anybody ever seen a histogram before? How come when your hand's going up, some of you are going, histogram? Okay, the only difference between a bar graph and a histogram is this. You're going to have a scale and labels, and the reason that they're together is because it's a flow of information. Okay, a bar graph is comparing things, and it's, how big this building is compared to that building, how many eruptions that one had compared to that place, how long is this river compared to that river. A histogram is a flow of information because it's done in intervals. There's a big word for you, intervals. Where have you heard of intervals before? Well, you've been in school long enough, you've been getting grades long enough. Can somebody tell me what the intervals are on the grading scale here at Heartland? Does anybody know the intervals for the grading scale? Just in case you're not familiar with that word, interval.
Like 90 to 100 an A.
90 to 100's an A. And?
I don't know.
David's like, all I know is what I got to do to get an A. Because David doesn't even think about what would be at the other end of the B. He knows B, he knows A. He knows the dividing line between A and B, Jonathan. Yeah? Right. So the intervals at Heartland are basically by 10, right? 90 to 100, 80 to 89, B, 70 to 79. I think they tweak it a little when you get down to the D, bottom of the C, and D and F. Hopefully none of you ever have to deal with that part of the grade scale. But you understand what intervals are? So if you were to graph grades and you put them in intervals of 80 and 90, you would create something called a histogram, which would kind of look similar. You'd have a scale down here. Say I put this as, these are the grades from 60 to 69. And that would be 1 bar. And these are the grades, this interval is from 70 to 79. And when you made this graph, they would actually flow together. That's really the only difference. Does that make sense? So you'd have so many people with 60 to 69, so many with 70 to 79. And right now some of you are thinking, wow, I don't know what the scale is, but that's already a lot of people all the way down to the 60s and 70s, hoping to see the one from 80 to 89 go way up. But there's an example in your book at bottom of page 6, and they got their information from their histogram on page 6 from a frequency table. 2 words for you: interval, 60 to 90, 60 to 69, 70 to 79. Those are called intervals. Those are no word comes to my mind except for interval. Those are the spans of information that you're grouping together. Those are the numbers that you're grouping together: 60 to 69, 70 to 79. And then there's another word on there called frequency. What does that mean? When you hear the word frequency, what do you think of? Somebody besides David or Kiara? Yeah.
Sound.
Okay, he thinks of sound. There's a reason you think of sound when you think of frequency, because sound travels in waves. So we're getting there. And frequency is?
How often?
Very good. How often? How often is the frequency? So how often how often does someone get a 60 or 69? 60 to 69 or 70 to 79. And that would be your labels. Got it? The bottom of page 6, they've got their example is roller coasters. Again, it should be easy to read, Dominic. Staying awake? Dominic, if you look at their scale on the left side, it goes from 0 to 15, and they tell us that it's not 0 to 15, 0 to 15 roller coasters, but the scale along the bottom here tells us the height of each roller coaster. And they tell us that the height is in, what's that little M mean? Meters. So there you have a histogram made of roller coasters. And by the way, this book was made in, somebody want to flip back to the beginning and see when the copyright for this book was. You'll find out that the information on roller coasters has probably changed a lot since this book was made. David? 2005. Anybody go to Cedar Point a lot? You go a lot? How many new coasters since 2005? Because I have not been to Cedar Point, I know, since 2005.
I'm pretty sure
I know, my life's so boring.
I haven't been there at all.
I think the dragster did open before 2005 because I saw it before.
There's at least 3 because they came up with.
Yeah, Valraven, Rougarou, Steel Vengeance, Gatekeeper.
But are the ones they keep making, do they keep making them higher or just more thrilling?
Both.
Which one's the highest?
Top row.
So the dragster's still the highest?
Yeah.
All right. This is telling us that there are how many roller coasters between 60 and 70 meters high? Look at your intervals, 60 to 69. Look at your scale, 3, 6, 9, 12, 15. Remember, those are meters. How many roller coasters are 60 to 69.9 meters high? Seth?
13.
He'll say 13. It's between 12 and 15, and since there's only 3 13, 14, and 15, I agree with Seth. It doesn't look like it's quite halfway, so 13. Everybody got that? Say amen.
Amen.
All right. Which interval has the greatest number of roller coasters? 60 to 69. Isn't that easy to see? Number 4. When the next roller coaster between 60 and 130 is built, where do you think it will be? This book was printed in 2005, and they gathered this information, and they said the next roller coaster built, their question to you is, and we should know this now because it's 14 years later, what interval do you think that would be in? The roller coasters built after 2005, what would someone predict? What interval would you predict it would be in? And you have to explain why. Zacchaeus.
120 to 129.
Okay, why?
Because there's already one in there. See if it makes a lot of money because people like it, because it's thrilling. Then they'll make another one with more money.
Makes sense that when they printed this book, their point was you had all these roller coasters like Blue Streak. They still got that?
Yeah.
Right? Right. So you laugh. You act like that's Kittyland now. Right? See, when I was a kid, Blue Streak was a big thing. Gemini, they still got that?
Yeah, that's what I'm saying.
Gemini was a really big thing.
That's pretty fun.
Because don't they race?
Yeah.
Two different coasters.
Sometimes.
Do it ready for that.
All right. But they kept getting higher and higher and higher. Back when I used to go, Millennium Force, they still got that?
Yeah.
That was really high. Magnum?
Yeah.
Yeah.
Magnum was actually the biggest challenge of my life.
How? Why?
Because I'm afraid of heights.
Really?
Remember that. When I get up on the heater those times, it was hard to get down. I'd look down, I actually get a little woozy. So I'm afraid of heights, but when you're young, you're more likely to try to prove something and defeat those heights. So I had to go on the Magnum. I just don't remember seeing much because I had my eyes closed the whole time. Because what's the worst? Anybody else afraid of heights? What's the worst part? Are you afraid of heights and you've gone on a roller coaster? Okay. What's the worst part of the roller coaster? Really?
Going up.
Oh,
Like suspended in air and looking down.
Yeah. David, really? The worst part for you was going down?
yes, because it's so fast.
Going down was way better
Yeah.
than going up.
It should be up because of the suspense.
Yeah, it's like.
I've been forever traumatized by that sound. The click, click, click,
Yeah,
click.
clicking
That's what I'm for.
As you're going
Yeah, the worst rides are the ones that go
hundreds of feet in the air, Brett. Okay. Back to focus. So you got time to work and quit listening to me talk. You're going to be asked on your homework, pages 7 and 8, to interpret graphs. We're going to do the first 5 together. Ready? Page 7. A histogram is a graph that shows data that are divided equally into, what was that word I gave you at the beginning? I said it might be a strange word to you. Starts with an I, yeah. Intervals. So you don't have to write this part. You'll start writing on number 6. Intervals, histograms, divide things into intervals. Number 2, what type of graph is shown to the right? The graph of the World Cup winners. What type of graph is that? Be as specific as possible. Cam, it's, yes, be more specific.
A horizontal bar graph.
Is it?
Or no, vertical. I mean.
It's a vertical bar graph. Number 3, how many times has Italy won? Look, these are simple questions. They are that easy. Second week of pre-algebra, how many times has Italy won? 3. It's simple to see, right? It meets the line perfectly. How many more times has Argentina won than France? 1. It's that easy. 3 minus 2, or 2 minus 1. Number 5. The frequency table shows when new states were added to the United States. So from 1787 to 1836, 25 new states were added. Then they went another, how many years? From 87 to 36 is 50. So then they went another 50-year interval. How many states were added? Look at the table. 13. Then they went another 50 years. How many states were added?
10,
Then they went another 50 years. 2. What were those last two? What two states were added between 1937 and 1986, Micah? Or Alaska and Hawaii in that order, 49 and 50. So if you were to make a histogram of that information, down at the bottom, you would have the years. You understand that? 1837 to 1886. And up the vertical side, you would have numbers. What would you put out here for your scale? You don't have to write this. Number 5. What would you put as your scale for your histogram in number 5? First of all, it would be years, right? I'm sorry, states. Years is down there. It would be number of states. What would you put as your scale? Anybody? Would you go, let me ask you this, would you go 1, 2, 3, 4? Makes no sense, does it? Because what's your highest number?
25.
So it would be silly to go 1, 2, 3, 4, all the way up to 25. It's unnecessary. Would you go like this? 20, 40, 60?
No.
No.
Oh.
Now, Casey, 1, 2, 3, 4, 5, all the way to 25. Too many. 20, 40, 60 doesn't narrow it down enough, I don't think. How about 10, 20, 30?
No.
You wouldn't even do that?
No.
What do you think?
5.
I think so too. You would go 5, 10, 15, 20. You have to go at least as high as 25 because that's your largest number. Everybody got it? Okay, I'm done. You still have 11 minutes. Number 6 through 14, 7 and 8. That's it.
Oh.